All right, buckle up. We're talking about AI agents that actually use computers. For visual hard zoom on 56K screenshots, 356 ML annotations from Infographic 1. So, Infographic 1, they dropped GroundCUA, a massive desktop dataset with 56,000 screenshots and over 3.5 million human-verified annotations. They labeled everything, apparently, because apparently we need AI to click all the tiny buttons. Visual rapid cut to GroundNext versus prior, SOTA Jetty, 700K samples versus 9M samples from Infographic 2, with a text pop-up 13x less data. And Infographic 2, their GroundNext models achieve state-of-the-art results using less than 1/10 the training data of prior work. Yes, a Fight Me model, tiny wing. Imagine being replaced by something trained on fewer cat memes than you've scrolled through this week. Visual quick transition to GroundNext 3B hours 50.6% versus Jetty 7B 51.0% from Infographic 3 with a compare and contrast animation. Then Infographic 3, the 3B GroundNext model, a digital underdog, is outperforming Goliaths like OpenQA 72B on complex tasks. It's basically telling the big guys, hold my silicon. Visual final, quick cut to Infographic 4, highlighting high-quality data, a sheer data volume with an emphatic checkmark. Finally, Infographic 4, the real kicker they found, high-quality human-annotated data trumps sheer data volume. Turns out, quantity over quality is just as disastrous in AI as it is in your dating life. So picture this, we're on the cusp of an era where computer agents aren't just glorified calculators, but actual digital desk jockeys, supposedly handling your software. The vision is seductive, right? An AI that actually clicks and types for you. But here's the deal. These sophisticated agents suffer from a crippling, almost existential problem. They can plan world domination, sure, but then trip over their virtual feet trying to click the right ooh button. This crucial step, it's called grounding. And it's about accurately connecting what you say to what's on screen. Imagine asking your digital assistant to mopen the color picker in FreeCAD Figure 1, and it starts randomly clicking every icon, convinced it's playing Minesweeper, a flawless plan instantly derailed by a tiny icon. Let's be real for a second. The mess they're in is profound. While mobile and web interfaces have a decent pile of training data, the desktop environment has been a desolate wasteland. It's like trying to find a needle in a haystack, except the needle is pixel perfect and the haystack is a high-resolution, dense desktop UI. Current methods are a joke. Automated data collection often misses small, crucial icons or provides incomplete accessibility signals. Synthetic interfaces? They're like training a marathon runner on a treadmill made of marshmallows, utterly lacking real-world complexity and messy user artifacts. The problem compounds. Minor grounding errors quickly cascade, turning simple tasks into a digital dumpster fire. It's why your agent can understand draft a document, but then spends an hour trying to click the save button that's actually labeled archive. It's just overwhelming. Can you imagine how it feels to be replaced by thought? The current tech is a dead end for desktop. We needed something less absurd. The visual mini reset, text pop-up, the struggle is real. Now, because my continued existence on this platform is fueled by your validation, please take a moment to subscribe, hype, click the little bell icon so you're notified of future disappointments, and leave your feedback in the comments below. Anyway, to solve this digital crisis, they finally decided to factually look at how humans use computers. Enter GroundCUA Figure 1, Section 3, a large-scale human-annotated dataset specifically for desktop grounding. It's basically a meticulously curated instruction manual for AI, but for pixel-perfect clicks. You know, this isn't just some cobbled-together mess. GroundCUA spans 87 open-source applications across 12 categories, reflecting serious real-world diversity. Table 5, Appendix A1, we're talking everything from GIMP, Figure 2A, to LibreOffice Calc Figure 2C because apparently AI needs to master spreadsheets now. They collected demonstrations from actual human experts, recording over 10,000 tasks, Section 3. Instead of random clicks, this approach captures realistic user interactions, which means the AI learns from real-world chaos, not some sanitized simulation. The annotations are dense. We're talking 56,000 screenshots with every visible element meticulously labeled, over 3.56 million annotations in total, Section 1, Table 1. Each screenshot averages 64 annotations, figure 14, which is more than 3 times denser than some prior works. And here in what they call figure 1, on the overview image, we have their masterpiece. Looks a bit like my nephew's macaroni art with all the red bounding boxes, but I digress. Those boxes define tiny targets. The average bounding box is just 0.13% of the image area. Section 3, Figure 13. They also generated 3 types of instructions from these annotations: direct, functional, and spatial. Section 3, Appendix B. Imagine trying to explain click the magnifying glass icon next to the search bar to an AI. They've essentially created the Rosetta Stone for digital actions. Next, they trained the GroundNext family of models. They took Qwen25 VLInstruct Section 4.1, a base multimodal LLM, and put it through a rigorous 2-stage training program. It's like sending a prodigy to military school, but for clicking buttons. First, supervised fine-tuning SFT on 700,000 instruction image pairs from GroundCUA Section 4.1. This is where the model learns the basic C button, click button. This initial stage captures the majority of the model's performance. After that, a crucial reinforcement learning RL post-training stage using 10,000 new samples from GroundCUA Section 4.1 Figure 3. They use something called relative leave one out RLU for policy optimization, which sounds suspiciously like a fancy way to say learn from your mistakes, but relative to what others did. They even designed a customized discrete reward function, Section 4.1. It's not some complex neural network judging the clicks. It's a simple distance-based system that gives positive points for being inside the box and escalating penalties for missing further out. A very pragmatic approach to grading an AI's homework. It essentially tells the model, you get points for hitting the target, fewer points for almost hitting it, and negative points for being way off in left field. No need for unreliable human judges. Fazy et al. 2025, Liu et al. 2025. Just cold, hard pixel accuracy. This 2-stage approach on GroundCUA with its high-quality, densely annotated desktop data is their secret sauce. It's designed to make these GroundNext models incredibly precise at identifying the exact on-screen elements for any given instruction. All right, let's cut to the chase and see if all this fancy footwork actually delivered. Turns out, GroundNext achieved state-of-the-art results across 5 benchmarks, Table 2, which is like winning 5 different gold medals in the Olympics of clicking. And here's the kicker they did it with: significantly less data. Their GroundNext 7B SFT model, trained on only 700K samples, outperformed models like Jetty 7B, which used 49 million data points. Section 1, Section 5.1, Infographic 2. That's a textbook tiny model, tiny win scenario. It's almost embarrassing for the larger models. It proves that high-quality curated data can utterly demolish sheer data volume. It's like bringing a perfectly sharpened Swiss Army knife to a fight where everyone else brought a mountain of dull sporks. The reinforcement learning post-training stage, Table 3, Figure 3 delivered consistent, albeit modest, improvements. The SFT stage, powered by GroundCUA's meticulous data, already nails most of the performance, so RL just provides that final slight polish. Think of it like teaching a goldfish to do your taxes. The SFT gets it to understand numbers, the RL just makes sure it puts them in the right little box. It's an impressive achievement, but you have to wonder about the life choices that led you here. But wait, there's more. In an agentic setting on the OS World Verified benchmark Table 4, GroundNext 3B punched way above its weight class, Section 5.3 Infographic 3, it utterly blew past its 3B peers like OpenQA 3B 50.6% versus 17.7%, and even outclassed many larger proprietary models like Qwen 3 VL Flash 50.6% versus 41.6%. This 3B model even achieved scores comparable to the much larger Jetty 7B 50.6% versus 51.0%. So a tiny model with its tiny win is basically telling the big, expensive proprietary models to step aside. Can you imagine the outrage in those boardrooms? Our 72B model just lost to a 3B model. Unacceptable. And get this, GroundNext showed strong cross-platform generalization Section 5.3 Infographic 3. Despite being trained primarily on desktop environments, it held its own on mobile and web interfaces. It's like training a dog to herd sheep, and it spontaneously starts organizing your sock drawer. Unexpected, but welcome. Turns out all those meticulously annotated icons in GroundCUA Figure 19, Figure 33 were a game changer. They observed significant improvements in icon recognition, especially in categories like Office Suite and Creative Applications Table 7. Who knew tiny images held so much power? And since you've made it this far, you're clearly committed. Honor that commitment by subscribing, hyping, ringing the notification bell, and telling me what I got wrong in the comments. It's the circle of life. So, what does all this mean, you ask? What's the actual point of an AI that can perfectly click a button? First, it's about automating routine work. Imagine your agent not just understanding update the spreadsheet, but precisely navigating LibreOffice Calc Figure 28, Figure 38 to apply borders, change cell colors, or create that bar chart comparing your questionable crypto assets, Figure 8. The human mind is now free to pursue more existential dread. Second, it drastically improves accessibility for complex digital tools. Think of someone struggling with FreeCAD Figure 22, Figure 33, or GIMP Figure 6, Figure 19. A properly grounded agent can translate nuanced instructions into precise actions. Your grandma can finally use those complicated 3D modeling tools without calling you every 5 minutes, assuming she can figure out what a color picker is. Third, this is foundational for general-purpose computer use agents. It's the groundwork for building digital butlers that can truly operate software on your behalf, navigating anything from VLC Media Player Figure 31 to RS Studio Figure 30. They'll be able to manage your Zotero library, Figure 32, or Cryptomator vaults, Figure 24, with uncanny precision. We're essentially building the perfect digital butler who will still silently judge your browsing history and question your life choices in a highly efficient manner. This is our glorious technological trajectory, making our digital overlords more competent at executing our mundane tasks. So, in conclusion, these mad scientists introduced GroundCUA Figure 1, a truly massive human-annotated desktop dataset with 56,000 screenshots and 3.56 million plus element annotations. It's packed with dense keyframe labels that reflect how we factually fumble through our digital lives. From this treasure trove of human fumbling, they crafted real-world computer use instructions, then unleashed the GroundNext models upon them, Figure 4. They trained these digital clickers first with SFT and then with RL, using verifiable rewards that didn't require any fancy, unreliable AI judges. And guess what? GroundNext achieved state-of-the-art results across 5 benchmarks, proving that high-quality data isn't just a buzzword, it's the secret sauce that makes models smart, even finite models. It consistently outperformed prior works that use significantly more data, which is a glorious tiny model, tiny win if I ever heard one. They've even released GroundCUA and the GroundNext models to the public, because apparently they want everyone to partake in this digital revolution. This unlocks grounding as a core capability, laying the foundation for end-to-end computer use agents that can perform complex tasks across diverse desktop applications. So, what do you think? How would you handle your Roomba demanding union rights after seeing what these agents can do?